This is AQA A-Level Chemistry, and this is the Year 12 topics Redox. This is part 2, and we're going to be looking at finding and determining oxidation states within this video. So, as always, I'm going to recommend that you try the activities, pausing the video as you go, and then you get a chance to review your progress and see what might need a little bit more focus and attention. So we need to know what oxidation state means, we need to describe how they're worked out, and we need to remember the rules that allow us to do that. There are numerous rules, very important that you do learn them, and you learn them so that you can go on to apply them. I'm going to put up all of them here. This is what you need to know. So any element in uncombined will be 0. The sum of the oxidation states in a compound is 0. In a complex ion, the sum of the oxidation states is equal to the charge on the ion. And then we've got things like group 1, always +1, group 2, always +3. And then we've got some much more specific ones. And I'm going to recommend you take the time to read through these. Hopefully you've got these as notes somewhere that you can refer back to until you're confident with them. Let's take a look at some worked examples of how we can use those rules then. So if we take a look at sulfuric acid and we want to know the oxidation state of S, sulfur, in sulfuric acid. Well, we can see that sulfuric acid has 2 hydrogens, each with an oxidation state of +1. And it has 4 oxygens, each with an oxidation state of -2. So we've got -8 from the oxygens and +2 from the hydrogens, and that means to get to an overall oxidation state of 0 for the compound, the sulfur must be +6. Now the best way to deal with these is to do examples. So I'm going to recommend you have a go at these and then review your answers. We want to know the oxidation state of the species in bold. So in the first example, we have got sulfur dioxide. Now we know that oxygen has an oxidation state of -2 generally. So that's 2 times -2, and that means to get to an overall charge of 0, the sulfur must be +4. For sulfur itself, because it's an uncombined element, we know from the rules that it will have an oxidation state of 0. In hydrogen sulfide, we have got 2 hydrogens. Hydrogen has an oxidation state of +1, generally speaking. So that's 2 times +1. So the sulfur must be -2 to get to the overall oxidation state sum of 0. And MnO4 -1. So for the MnO4 -1, we have a few things to consider. In the first instance, we know that we have got 4 oxygens, each with an oxidation state of -2. That's a total of -8. Now to get to -1, which is the charge on the complex ion, the manganese must be +7. So let's try some more. In this case, we've got a complex ion once again. So I've got 7 oxygens, each with an oxidation state of -2. So that's -14. That means to get to -2, my 2 chromiums must have a total of +12. But I've got 2 chromiums, which means the oxidation state of chromium here is +6. In copper oxide, and there are 2 copper oxides you can see here, the copper oxide that we see first, the oxygen, has an oxidation state of -2, so the copper is +2. And that's why that copper oxide would have the proper name copper 2 oxide. For the next copper oxide, once again, oxygen is -2, but this time I've got 2 coppers that will give a combined oxidation state of +2. So each copper has an oxidation state of +1, and that would be copper 1 oxide. And then if I look at the ICl7, quite an unusual compound, I know that chlorine is -1, so that's 7 times -1. So in this circumstance, iodine actually has an oxidation state of +7. Remember, use the rules if you need to use them. Go back and refer to them. Look back in your notes until you're confident. Try these final ones now. So in this case, I've got nitric acid, my H is +1, my 3 oxygens come to -6, and that means that my nitrogen is +5. When I look at ammonia, NH3, I've got 3 +1s from the hydrogens, which means my nitrogen must be -3. The next one, we've got to remember one of the exception rules, because group 1 is always +1. And that means that the hydrogen in this circumstance must be -1. It says in the rules that hydrogen is +1 except in a metal hydride, and that's what we're seeing here. And then we've got hydrogen peroxide. Here, hydrogen is +1. That's 2 times +1. So each oxygen must be -1. And finally, F2O. So my fluorine is always going to be -1. I've got 2 -1s, which means in this circumstance, my oxygen actually has an oxidation state of +2. That takes us to the end of this video. Thank you for listening. Goodbye.